One of the several things that frustrates me about your textbook is the way it handles terminal zeros in numbers without decimals and whether or not they're significant. One of the things I dislike about your textbook is the rule for dealing with terminal zeros. Zeros at the end of a number with a decimal may or may not be significant. This rule I don't like from a rule standpoint, but it actually kind of reflects what you see in reality. What do we mean here? Well, for example, you'll often see lab instructions that will tell you to measure 10 milliliters. How many significant figures in that reading? Well, anybody who's worked in a lab knows that it's very easy to measure 10 milliliters, and to measure 10 milliliters with a great deal of precision and accuracy to that volume. So your average person would look at that and say it has 2 sig figs. The same could be said for somebody told to measure 200 milliliters. A person could look at that and say, hey, that has 3 sig figs. The issue is, however, we don't know that for sure. Why is that? Because zeros are often used to hold place values. For example, let's look at a measurement that would be very much a gray area. I tell you I have 20,000 kilograms of something. How many sig figs there? Well, we know for a fact it has at least 1 sig fig. What we don't know, however, is did the person measure to the nearest kilogram, or the nearest 1,000 kilograms, or the nearest 100 kilograms, or the nearest 10 kilograms? All these zeros, we don't know if those zeros represent something the person measured, or whether those zeros are simply there to hold place value. And that's the reality of the situation. Most people aren't analytical chemists. If you're an analytical chemist or a p-chemist, you're screaming at this point saying, you idiot, write it in scientific notation, and that way we know exactly which of those zeros are significant and which are insignificant. And if you're an analytical chemist or like me, or a p-chemist, this rule makes you very frustrated. However, the reality is we have to deal with organic and inorganic chemists in our everyday life. You know, you just have to put up with them. Hey, they're much better than biologists. I mean, please tell me. But at any rate, the reality is you'll find people writing measurements using zeros to hold place values, and at the same time some of those zeros are representing something significant, which makes it really hard as you as the reader to know how many sig figs. This measurement could contain anywhere from 1 to 5 significant figures. If I asked you on an exam how many significant figures were in this measurement, I'd have to accept anywhere from 1 to 5. No choice in the matter. In my mind, this boils down to sloppiness. In reality, the person who took this measurement should have put their answer in scientific notation. They should have said, hey, I measured to the nearest 10,000 kilograms, so I should have written my number like this. And that way I could see that you have 2 sig figs. Or, if you measure to the nearest 100 kilograms, you should have written your answer. And then I know exactly how many sig figs you have. Or you should have written your answer if you measured to the nearest tenth, or if you measured all the way to the nearest kilogram, that number right there, then you should have written 1, 2, 3, 4. In my mind, that's what the person should have done. That's what your average analytical chemist or your average p-chemist would have done. Unfortunately, the world's not populated that way. Therefore, we have to deal with these ambiguities and zeros. And you know what? Dirty confession, I'm guilty of this too. I will tell people to measure out 10 milliliters. And I will mean that, actually, when I say 10 milliliters, I'm probably wanting 10.0 milliliters. But I will mean that they're measuring it to at least the nearest milliliter with some degree of accuracy. Therefore, there's a great degree of ambiguity. What does that mean for you as the student? Let's address a practice question. How many sig figs in the following number? All right, how many sig figs in the following number? Well, we know anything that's not a 0 is significant. So I know those guys are 3. Those 3 numbers are significant. I know that any 0 that lies between non-zero numbers is significant. If I can measure this place value and I can measure that place value, then I can measure these place values. So my number that I've given you has a minimum of 5 sig figs. Those are definitely significant. We have ambiguity in these last 2 zeros, though. They may or may not be significant. Why? Because our number's not in scientific notation, and zeros are used to hold place value. So our number could also have 6, or it could have 7. So if you're being given a choose the correct number of sig figs, you would have to choose 5, 6, and 7. Because all of those are possible numbers of sig figs represented by that measurement, because the person was sloppy and didn't write in scientific notation. Are my true feelings on this matter showing? All right, let's look at another one. How many sig figs in this measurement? Well, once again, anything without a 0 is going to be significant. So we know that we have a minimum of 3 sig figs. And once again, we have zeros at the end of a number without a decimal. So any of those zeros could be significant. So our answer could be anywhere from 3 to 9 sig figs. We really don't know because, again, whoever did this was too sloppy to write it in scientific notation. In reality, since the number is very, very large, so in reality, it's more likely than not that there's only 3 sig figs since the number is so large, and that these zeros are simply holding place value. But we don't know that for 100%. Scientific notation really is the solution to this problem. I think you're probably with me at this point. If you're not, contact me again, and I'll be happy to take another whack at it here. Let's work one more example to make sure that I haven't confused you with a different rule. 2 last examples here to make sure that you're not messed up on what you had previously understood. How many significant figures in this number right here? We know anything that is non-zero is significant, so those 3's are significant. A 0 between 2 non-zero numbers is significant. Now we have a game changer, folks. We have a decimal. Bum, bum, bum! Since we have a decimal, and these zeros are now at the end of a number with a decimal, these zeros have to be significant. They're no longer optional. Zeros at the end of a number with a decimal are significant. We don't need to write this 0 in order to know the place. We don't have to write this 0 to know the place value of this 3 or that 0. Therefore, the only reason to write this 0 is if we measured it. If we measured this 0, or the person giving us this measurement measured this 0, then they also must have measured this 0 as well. So there's only one possible answer. Like Highlander, there can be only one possible answer to this question. This question has 5 sig figs. No ifs, ands, buts, no hesitation. Because now we're dealing with zeros at the end of a number with a decimal. Everything else we had talked about up till now had been about numbers without zeros, without decimals at the end, right? But now we're talking about zeros at the end of a number with a decimal. One last example. How many sig figs in this number here? Zeros before a non-zero number are insignificant. So these zeros, not significant. Now we have a non-zero number, so it's significant. We have another non-zero number, so it's significant. We have a zero between two non-zero numbers, so it's significant. Then we have zeros at the end of a number with a decimal. That decimal makes all the difference. If decimals were sold in stores, that would be their slogan. Decimals, buy them today, they make all the difference. Increase your sig fig power by adding a decimal. These zeros are at the end of a number with a decimal. Therefore, they're significant. By rule, they're significant. So once again, with zero variation, this has to have 7 sig figs. All those are significant. Hopefully that clarifies things a little bit and helps you a little bit on the homework. Beep.